Good morning. Today is Sunday, 19th January 2020. And I'm Christopher, AE7XQ. So that doesn't sound right, does it? Or does it not look right? Let's see, no hat. And I identified with an amateur radio call sign. I'm up to something. Of course I'm up to something. We're being a little more scientific today, shall we? Now, I've railed about flat Earth before, and how stupid I think the idea is. Any flat Earth types, you're welcome to try to debunk me all you want. But, as a U.S. military veteran, and this cup came from the ship that I served, so good luck trying to debunk that one. I want to talk to you. You guys got a problem. A huge, glaring scientific problem. Have you ever wondered what the Achilles heel is when it comes to flat Earth? Yes, there is an Achilles heel that is a weakness in the flat Earth argument. No matter what you do, what you say, no matter how hard you try to adjust the facts to fit your view, you've got one glaring problem. I can show you your problem. It's sitting right here on my desk. And there are thousands of others like me who have one of these. Not necessarily my particular make or model, but it is your Achilles heel. This is a handheld amateur radio transceiver for the amateur 2 meter and amateur 440 band. That's 77 meters. Now, how is this an Achilles heel for flat Earth? Well, practically speaking, I don't know. Maybe it's not. This is the Yaesu FT470. I'm just going to tell you right now, as you see it in my hand, it's not really much of a problem for flat Earth. Then again, radios in the 2 meter and 440 bands, well, they're not typically designed with a lot of power in mind. Though, with the right equipment, you could legally get away with up to 2,000 watts out. Though here in the United States, the FCC rules say minimum power necessary for communication. Minimum power. Now, that's often misinterpreted. There are a lot of guys out there who, unfortunately, minimum power for them is nothing less than legal limit. In ham radio, we call that QRO, or running high power. Me, I rather run the opposite end of the spectrum, QRP, or running low power. Now, these terms, QRO and QRP, their meaning is a lot more technical, and I'm just running on, right now, the base meaning. That is how we typically use the terms. Now, the problem with running QRO, or really high power, is that maybe somebody who is running QRP is trying to get a message, especially if it's a message involving life and safety. And if you're running QRO, you may actually end up doing what we call QRM, or interference. There are all sorts of rules about this. Now that we've established that premise, QRO, QRM, and QRP, what is this Achilles heel? Well, flat Earth theory has not, to date, been able to, in one way or another, give a valid, functional explanation of RF energy. That's right. Radio waves. Let me give you a couple examples. Now, let's play first with just me. I am, after all, a licensed amateur band radio operator. Now, not that radio, but I've got a couple of other radios here that I use. One of them is a Heathkit. It's called the Sixer by nickname. This device, it's an AM radio, transmitting at 50 megahertz. Well, in the 50 megahertz band, which goes up to about 54 megahertz, if I remember the band plan right. Whatever. Now, I've got an antenna on top of my house. It is a beam antenna. If you recognize the old TV aerial antennas from the late 70s and 80s, even going into the early to mid-90s, if you know those antennas, looking at that antenna on my house, you'd think that was, in fact, one of those old TV antennas. You'd be wrong, but I prefer to let people be wrong. Now, that antenna, let's say I were to point that due south of me. So we're talking, I'm pointing it down towards roughly El Segundo, California. That's more or less a straight line down for me. And let's say I do this at about, I don't know, how about 6:30 in the evening? Now, why would that matter? My antennas point southward at 6:30 in the evening. Now, let's say I go ahead and crank the power on the radio up to about, I don't know, 75 watts. I like it running on the lower end of power, because that's what I do. Now, I start transmitting. I probably do something simple like AE7XQ monitoring, or something to that effect. When trying to initiate a call on ham radio, especially if you're running what we call simplex, there's all sorts of etiquette involved. And I'm not really here right now to try and get involved in the etiquette of things. But it exists, and it's worth looking into. However, let's say I call out, and then I just sit and I listen. What if I told you that there have been times when I've been sitting there listening, and all of a sudden I'll hear my own voice come back to me. I might faintly hear the first two letters of my call sign, but I'll definitely hear, albeit faintly, 7XQ monitoring. This has happened to me. So, flat earthers, what happened? Well, I can tell you, but let's now run a hypothetical, shall we? Let's say you take two guys. Just two guys. And let's say one decides to go to Dutch Harbor, Alaska. And the other goes to a place roughly the same longitude on the other side of the planet, somewhere in Russia. They point their antennas at each other. And for 2, 3, 4 days, they just simply talk to one another, let's say I'm going up, down, across the North Pole. Now, most flat Earth maps I've seen allow for that. No problem. Now let's have a problem. Let's take our two guys, and let's say after a few days of this, they're going to go to the bitter tip of South America and the bitter tip of Africa. I'm choosing these areas because they're the two closest to the Antarctic and Antarctica itself, which most flat earthers affirm that is really just an ice wall. And this is where things get problematic. Our two guys get down to their respective locations. The very tip of South America, the very tip of Africa. And again, they point their antennas at each other. Same lines of longitude. Now, they start transmitting. For 3, maybe 4 days, they talk with one another. Across Antarctica. Now, radio signals don't care about geographic boundaries or anything stupid like that. So, the base in Antarctica is going to hear them. Fine, whatever. Typically, the base in Antarctica doesn't monitor amateur radio frequencies, but there are some guys there who are licensed ham radio operators, so they might hear something if they got the equipment with them. No big deal. Now then, what's happening here, guys? Seriously, come on, flat earthers. If your theory, I can't call it a theory, if your belief is so accurate, if flat earth is so indisputably true, what's happening with the radio signals? Both my scenario, which has happened to me, and my hypothetical with two guys who've gone all the way down to South America and Africa and are transmitting to one another. What's going on, guys? Come on. Tell me. What's going on here? And this has been going on for over a century. Long before we could attach our phones to our radios. So long before auto patch was a thing. We're talking, this has been going on even back in the days of Morse code. And we didn't have the equipment necessarily back then to take an incoming radio signal, push it through a phone line to listen to it again. It didn't work that way then. So what's going on? Huh? Not to mention, how? What's going on and how? Huh? Now, there is a scientific explanation based upon the idea that the Earth is a spherical object. Now, in my instance, that is with my antenna pointing southward during what is ultimately twilight, we have what's called long-path radio wave propagation. What's happening is that the terminator between day and night, if you will, is creating a path for my signal to travel around. Now, there's a lot of science involved in this, and I can't say that I have perfect understanding. I don't. But the fact is, my signal's traveling along this twilight path, which we call gray line propagation. And it's going all the way around the planet. The signal's not just going to shoot off into the distance somewhere it can never be heard again. And that's because of what's called the ionosphere. It kind of keeps the signal here on Earth. Not to say that some of my signal probably didn't bleed out into outer space somewhere, but whatever. Doesn't matter. Now then, what's going on, guys? Also, with our two guys who are actually running a short path from Antarctica to Africa. How are they getting a signal across Antarctica if, as you guys claim it, Antarctica is really just an ice wall around a plate? Come on. I want a real answer that's testable. Not to mention there's a bigger problem. I want you to think about this. Gray line isn't the only way that we have long-path radio wave communication. I haven't done this myself, but I've watched other guys transmit going east-west and hear their signal. I've also seen people point their antennas north by northeast and hear their own signal. Now, typically high sunspot type days are when these things happen. And that's all well and good. That's just science, no big deal. Now, if the Earth were flat, long path radio wave propagation in any direction would be impossible. And this gets to why I mentioned earlier the idea of pushing a signal into a telephone line. Now, we call that auto patch. It's a product of the late 50s, early 60s, somewhere in there. Now, it was kind of a neat idea at the time. You could dial into your phone, as it were, from your radio, and make a phone call. So you call, say, your mother, and say, "Hi, I'm calling you from my car. I'm in, I don't know, Spokane. I'm headed towards your place. Maybe your mother lives in Boise." So you're radioing back to your home using a dialer device from your car to dial your phone, call your mother over the radio to talk to her. That's cool. Yeah, that's really, really cool. And I've gotten to use that idea to some extent myself. In the earlier part of my time in the Navy, I got to call home from ship over the radio. That was cool. That was really cool. But, now think about it. And this is the but. But that's a lot of technology and infrastructure just to do that little bit. That little bit. Now, imagine the type of technology and infrastructure you would have to be able to pick up a signal, put it through a telephone line, know exactly where you need to send it to retransmit it to give the impression, as it were, of long path radio wave propagation. Sorry guys, not buying it. It doesn't work. The fact is, we can measure how long a signal should take to reach someone. We typically measure it in milliseconds, because radio waves travel at the speed of light. So, okay guys, all really is in your court to try and explain this. The amount of infrastructure it takes to build a network on the outer ice wall, as you believe exists, to pick up, move, and retransmit a radio signal with exacting precision, borders on the impossible. Not even ludicrous. Impossible. And you would have to have this system in place literally at the dawn of radio. I'm not buying it. I'm just not buying it, guys. There's no way on Earth that you could have a system in place that far back that could pick up a radio signal and move it around the stinking disk. And yes, if there's a disk, it stinks. There's no way you could have a signal that could just go spinning around the disk. It just doesn't work. Come on, be real. Now you might try and argue, oh, that's not what happens. The signal goes all the way to the ice wall, bounces off, goes back the other direction, bounces off again. Nope. Not happening, guys. If a radio signal bounces off of something, it's likely to scatter, creating multiple signals. all have more or less the same signal, but slightly distorted. And radio operators, we've been bouncing signals off meteors, off the moon, and off other things for decades. So, we know what that singing garbled signal sounds like. Not buying it, guys. Not buying it. Not only that, but like I said, we've measured how long it should take a radio signal to travel from one end to the other. Do you know how much time it would take for a signal to bounce from where I live to your proverbial supposed ice wall, to the other side of your ice wall, and back? Let's just say that it's about 1.35 times longer than a direct circle route would be. And I'm just giving an approximate number based upon your maps and what I know about the time it takes for a radio signal to go around the globe. I might be a little off, and I'm fine if my numbers are off. I'm not trying to be perfect here. I'm not trying for exactness. What I'm trying for is to make a point. If the Earth were flat, long path radio wave propagation can't happen. It just can't. It's impossible. Utterly, thoroughly impossible. Ball's in your court, guys. If the Earth is flat, and I'm not buying that, how does long path radio wave propagation work? Oh, I would love to bet you guys money. I would love to bet the Flat Earth Society $2 million, but I can't. Because I don't have $2 million. They do. In fact, I bet they have hundreds of millions of dollars by now. From all those people that they've scammed over the decades. Balls in your court, still flat earthers. Tell you what. Prove to me that the Earth is flat based on radio waves, and I'll join you. Fail? You need to find a way to pay me. And I like cash. Lots of cash. In fact, I'll put this charge directly to the Flat Earth Society itself. Prove from radio waves that the Earth is flat, or put out a global announcement that you have lied for decades and shut your doors forever. I think I'm being reasonable, because flat Earth is a lie. It is a demonstrable lie. I don't need radio to prove it, but radio is the Achilles heel. There is no way that radio can work the way it does if the Earth is flat. AE7XQ. Best regards. 73's all.